So this chapter of potential energy is required in your class 11 physics as well as class 12 physics. If you have proper concept of potential energy which is based on conservative force, then you are the winner, I will say, because work energy power is very conceptual topic. This topic can be related, I told you in the previous class, in all the following chapters. Even I'll show you some problem in circular motion, how can be solved with the help of potential energy. Okay? So this session is going to be very important and I think interesting also for you. Maybe some mathematical deductions will be there, but finally you will find the concept in it. Okay? Then what is potential energy and how does the concept of potential energy arise? To understand it, we have to go back to work energy conservation theorem. Hope you all remember what is work energy conservation theorem. Work energy conservation theorem. You got the idea of kinetic energy, you got the idea of potential energy also, but that idea of potential energy was vague for you. You don't know from where the potential energy concept arises. Body is in motion, it has kinetic energy. So long it is in motion, then it has kinetic energy. If it stops, kinetic energy is lost. But where does the kinetic energy go? And why the concept of potential energy arise, that you have not learned. Let us start with the work energy conservation theorem. That work done by net force is equal to change of kinetic energy. See, nothing is told about the concept of potential energy here. This is just work done by net force equal to change of kinetic energy. Net force means what? What is net force? If we take net force as F net, then F net going to be F conservative, that you don't know, F non-conservative, that also you don't know, F internal, this you know, plus F internal plus F external. Sum of all these forces will be equal to the net force. And work done by net force, how did you write that F net into dx? If you write, this is going to be, if you find it from A to B, then this is nothing but kinetic energy at B minus kinetic energy at D. You can write half mvv square minus half m v square. This is work energy conservation theorem. This is just kinetic energy work. You can say work energy conservation theorem, but this is basically kinetic energy work conservation theorem. So, how the work is being done? That is by external force or net force or non-conservative or conservative. There is a source of energy over there. Source of energy is there then some work is done, and we finally get the change of what? Kinetic energy. If Vb is greater than Va, we can say that kinetic energy increases. If one thing I would like to say, if work done is positive, then kinetic energy increases. But work done may be negative. If negative work is done, then kinetic energy decreases. Okay? So I am assuming that it is increased. So work is the factor. From source of energy, if some work is done, then kinetic energy will increase. So to change the kinetic energy, work has to be done. This is our basic fact. Now, if I go by one example for you, you may not find this one true. I am telling you. Suppose the body of mass M is there on the ground at the point A. You have taken it at the point B, which is h meter above the ground. H above the ground. And take the mass M slowly from the point A on the ground to a height h at B above the ground. What is your observation? If it is taken from the point A to the point B, then what is happening? And you have taken it slowly. This particle you have taken slowly from the point A to the point B. Take the mass M slowly. I have mentioned that. Again I am mentioning here. Why? No acceleration given. No force acted on it. You will say that without acceleration it is being moved. Without change of velocity it was moved. Velocity at A is 0 and velocity at B is also 0. Okay? What is the force acting in downward direction? Minus mg. What is the external force? That is mg. Okay? So, against the force of gravity, the external agent has applied the force equal to it in opposite direction and moving it slowly above the ground from the point A to the point B. From A to the point B it is taken. Now can I say that work done equal to change of kinetic energy here? Can I say work done equal to change in K? Can I say that? No, it will be wrong. What is the work done? That we have calculated before. In the previous session, work done will be what? External force applies a force mg. External agent applies a force mg and that into h. mgh. Can I say that this mg is equal to change of K? No, will be wrong. So, work energy conservation theorem is not valid over there. Okay? The theorem, obviously, this is not true. This is not true. We assume the existence of another type of energy here. We assume that a different type of energy is increased. We'll refer this energy as potential energy. This energy will be potential energy. Okay? So in this case, what will happen? In this case, we will say that work done equal to change in potential energy. Okay? We have taken the object slowly above the ground, but if the object is taken with more force larger than mg, then what will happen? If we have taken to the same height, then the velocity here will not be velocity here, velocity change. Okay, if we take velocity at A as VA and then finally it is at B, at the point B as VB, then this potential energy which we have referred there, that is changed, as well as kinetic energy also changed. Okay, so work done equal to change in K, work done equal to change in P, that we will not write, we will write work done equal to, so work done by net force that we refer as change of kinetic energy, that's true. And this net force, if we write, F net the way I have written before, F conservative, F non-conservative, F external, F internal, then we have to write Fc plus Fnc plus F external plus F internal into dx equal to change of K, that is Ke at B minus Ke at A. Okay, so in that case, source of energy here, if you write, what is happening? Source of energy in this case, by doing work, kinetic energy increases. In this case, let us write that for potential energy. Source of energy, but by work done, what you have done, that mgh work is done. So source of energy was there. Source of energy and then work done, and then what we have got? Increase in potential energy. So from source of energy, by doing work, both K and P can be increased. Okay? So this implies that we have seen before increase in K, here increase in P. So by doing work, both K and P can be increased. Okay? And work done by net force, that we know, change in K. Now let us see what is happening there. What is conservative force of field, that I have to mention first. And non-conservative force what? Then I will continue with this equation only. We will work on it after introducing the concept of conservative and non-conservative forces. We will come back to this equation, but after finishing the concept of conservative and non-conservative forces. Okay? Because to proceed this one, we need the concept of conservative, non-conservative, external, internal, that you know. Internal forces in most of the cases 0, because they get cancelled. External force not 0, but conservative, non-conservative, let us know first. What are conservative forces? Because we are relating potential energy here with the work done, so conservative force plays vital role. We will prove that potential energy is the case of conservative forces only. What is conservative force? Just you imagine that an object is taken from, it is projected from here with some velocity u at the maximum height. At maximum height v will be equal to 0, and when it comes back, when it goes down, that velocity is recovered, that you know. So what is work done by gravity in this case? Tell. Work done by gravity, just we have seen, if the height is equal to h, that W up plus W down, what is that? What is work done to move it upward? Minus mgh, because this work is done against gravity. And W down will be what? mgh. This is 0. Work done by the gravity in this path A to B, then B to A equal to 0. Okay? This force of gravity will differ as force of gravity is a conservative force. Why conservative force? That force is said to be conservative if work done in a round trip. A force is said to be conservative if the work done in a round trip is equal to 0. This is round trip, no? You have gone from the point A to the point B, then from B to the point A. The net work done is 0 and the force will differ as conservative. Any other example in your mind for conservative force? That conservative force where work done 0, that will be conservative only. I am just writing 2 more examples here. That electric force. Electric force is conservative, other examples. But this is beyond our scope now. This will not do more. Electric force is conservative. electric force, spring force. Spring force, you have the idea. I'll show you some example based on spring force also. So this force is said to be conservative force, where work done in a round trip 0. Just for another example I tell you, suppose you have taken an object from A to B, then from B to C, and then from C to A. Okay? Taken an object from A to B, B to C, C to A. Is this force conservative? I mean, the force acted on the object is conservative or not? That you have to decide. Why? Because work done in this path ABC is how much? Work done in AB plus work done in BC. So work done in AB is what? 0, because gravity acting vertically downward, and this displacement perpendicular to the force, it has no component. Work done in BC is what? External agent doing work or gravity, whatever you assume, that gravity, mg into minus h, if h is the height. Exam no. And this part be theta. This is WABC. A to B, no. That we have calculated W, A to B, B to C. But C to A we haven't done. C to A will be how much? We have to add here WC to A. What is WC to A? This work is being done by gravity. The force is mg sin theta here. And this work done is positive. Why? Because work is done by the force of gravity. So you will be adding it over there. This is mg sin theta into AC. This is what? Minus mgh. This is plus mg into AC sin theta. What is AC sin theta in diagram? H by AC equal to sin theta. So AC sin theta will be minus mgh plus mgh, that is 0. Okay? Now, two things are very clear from this example. What is that? That is, if the particle taken from A to B and then from B to C, only if you consider WABC, we have calculated it. What is that? Minus mgh. WABC is minus mgh. This minus mgh means it depends on A and C. If we have taken vertically through the same height here, work done will be the same. It is not dependent on the path. Now from C to A, what is the work done over there? That is plus mg. That is also plus mgh. They get cancelled. Now suppose you have calculated that work done in the conservative force of field from A to B and then some height above the point C, vertically above. Then work done will depend on what? The point A and the vertical height. So in case of conservative force, the net work done in a round trip, this is round trip, no? ABC a round trip 0. But work done between any 2 points here, in case of conservative force, work done in a round trip equal to 0, and between any 2 points work done depend on the initial and the final position. Okay? Work done depend on initial and final position, and most important thing is that is work done is path independent. In future you will find it for electric force also. Work done between any two points is depend on the position vectors of those 2 points, not on the path. Any path you take. In our example, I just show you. Work done, suppose from A to B you have taken this way. So just I showed you, it is height h, mg. Somebody has taken the object this manner. Do you think same work done will be there? We have taken from A to C via this path and then via this zigzag path. Work done will be what? It will depend on the vertical height only. In both the cases, this way work done, WAC and WA to B to C will have the same value. Okay? It depends on the vertical height here. So this is the case of conservative force. Now, conservative force, 2 more examples I told you. We will work with spring force and in class 12 with the electric force. Right now you have to understand a non-conservative force. What is a non-conservative force? Then measurement of potential energy can be done properly. What is non-conservative force? I just give you one example. Suppose there is a block resting here. Non-conservative force. Non-conservative force means work done. The first definition I can write here. Work done in a round trip is not equal to 0. Okay? So, from the point A to the point you are taking the object where there is friction. Can you tell me how much work will be done? Let the distance between 2 points AB equal to L and mu is the coefficient of friction. Object is a mass M. It is taken from A to B. You all know it. The work done will be what? Against the friction. Minus mu mg into L. Why minus? Why minus? Because the work is being done by external agent and it is done against the friction. So, by external force if you say, it will be mu mgl. WAB by force of friction will be what? Minus mu mgl. Now, WBA is what? By external force. That is also mu mgl. Then what is the net work done by external force in a round trip? Net work done by the force of friction in the round trip A to B to A will be 2 mu mgl. This is not equal to 0. You can say that external force I don't know conservative or non-conservative, but I want to tell you in terms of force of friction also. এটা হচ্ছে by external agent. It is just we made the force equal to the force of friction, we got positive. By friction, how much work will be there? This we are going to calculate work done by friction. How much work will be there? WA to B to A, that is WA to B plus WB to A. WA to B is what? We are going to state the force of friction is non-conservative. WA to B is what? Minus mu mgl minus mu mgl. minus 2 mu mgl. Agree or not? So this is also not equal to 0. Work done by force of friction is also not equal to 0 here. Clear? So force of friction will be referred as non-conservative force. Therefore, force of friction is a non-conservative force. Any kind of friction, that is when you are taking the body vertically upward, air friction act, that air friction also non-conservative. Okay? Now we'll go back to the equation. Which equation that we left over there? What is that? It's very important. Very important idea. This we have seen. FC, FNC, F external, F internal equal to this. And the concept of conservative, non-conservative force we have got. We will be using this equation now to calculate the value of potential energy. How to bring potential in the equation, that I am going to discuss here. See, what are the forces over there? Conservative force, maybe anything, those three kinds in our mind. Non-conservative, force of friction. This is external force. This is internal force. Assume that if NC equal to 0. No non-conservative force is there. Forces are conservative ones. F internal in general get cancelled, always F internal 0. Why? Many particles are there. Force experienced by A due to B equal to force experienced by B due to A. So that is 0. Then what do you get in the equation? We get, by using this equation, F conservative plus F external dx. Put the integration sign, otherwise it looks short. A to B. Dx we have taken, no? Fc plus F external dx A to B equal to Kb minus K. And this we simplify this manner, that is A to B F external dx will be equal to Kb minus Ka minus or plus A to B minus Fc dx. Can you follow me? What I have written there? Minus Fc dx. Okay? This minus Fc dx, see, we have already mentioned that work done will imply change of K and change of P. Isn't it? Work done will increase both. I mean, you are taking the body with some velocity from A to B. With some velocity increased, potential energy also increased. So, this part for kinetic energy, you will keep it for what? This part will keep for potential energy, change of potential energy. Okay? We will denote, we take A to B minus Fc dx equal to potential energy. Potential energy normally we denote by the letter UB minus UA. Okay? So minus Fc dx is UB minus UA. Change of potential energy. That is delta U. So you can derive this equation now. A to B, if external dx will be delta k, change of k plus delta u, where delta u is given by this thing, that is minus fc dx from A to B. Okay, that is change of potential energy. Minus sign you can keep inside, doesn't matter. So work done by external force, change of K and change of P. External force will do work in such a manner that it can increase both K and P. But there may be situation where kinetic energy increase, potential energy decrease, or potential energy increase, kinetic energy decrease. There may be situation like that. But all these are going to be the related to change of K and P both when external force comes into effect. Now tell me one thing. I have introduced the concept of this potential energy, change of potential energy from where? By putting non-conservative force and internal force 0. Internal force why 0? That is easily understood. But non-conservative 0, if we don't put non-conservative 0, we cannot use the concept of potential energy. So the change of potential energy or potential energy will be related to conservative forces only. Okay? So in the field of conservative force, potential energy will exist. If it is non-conservative, there is no link with potential energy if it is non-conservative. Now, this delta U you are writing minus Fc dx. Okay? A to B. If we just write delta U by delta x, and when delta x tending to 0, then we can write du just by taking differential equal to minus Fc dx. Therefore, Fc going to be minus du by dx. So conservative force is given by negative gradient of change of potential energy. Clear? It's okay? Now one thing. So again we start with this relation that A to B, if external is del K plus del U. In the sense of calculus, this treatment is not very mathematical for you, but understanding will not affect. Okay? Not very mathematical. Why I will say that? A to B if external dx, then external force increases both K and P. So in a system, if external equal to 0, then del K plus del U will be 0. What is del K? Del K stands for what? Change of kinetic energy, that is Kb minus K. And del U is what? UV minus UA. So what does this imply? Therefore, Kb plus UV equal to Ka plus Ua. That is total energy at B at this stage. This is one stage, this is another stage. Total energy at B equal to total energy at A. This is called principle of conservation of mechanical energy. This is called principle of conservation of mechanical energy. Conservative force is present there, but other external force is absent. In that case, conservation of energy is valid. Okay? So, how will you solve a problem based on this? That I am going to discuss. So, this potential energy, kinetic energy will remain conserved between 2 points if only external force is absent. I just give you one example. When an object falling through an inclined plane suppose the object is taken at height h above the ground. We want to prove that if it is allowed to fall, obviously because this is frictionless, no friction is there, external force is absent. So at 3 positions of the object, this is not increased suddenly, same object. This point is A, the object is here at A, then the object is at B, then we have taken it at C. It goes to the point C, same object. You have to prove that total mechanical energy is conserved. But energy is being converted. Interconversion of energy takes place. But total mechanical energy is conserved at A. At A, Ka plus Ua, how much? You have just released. Tell kinetic energy at A is 0, potential energy is what? mgh. At B means the distance between these 2 points be x. Incline makes an angle theta, here also it will be theta. This part will be how much? X sin theta. At B, kinetic energy is what? Tell half m v square. And potential energy mg h minus x sin theta. Am I correct? Potential energy is mg h minus h sin theta. But how to get half mv square? Along this direction, the force is due to gravity, acceleration g sin theta. Now v square is what? 0 square plus 2x into acceleration. So 2g x sin theta. How to get x sin theta? This point be m. am by ab equal to sin theta. Okay? am by ab equal to sin theta. So am going to be ab sin theta. Okay? am is ab sin theta, that is x sin theta. v square is got. So today, and potential energy is what? This thing. So you find UB. UB is mg into h minus h sin theta. Kinetic energy half mv square, and this part is potential energy, UB. UB is this. So you just find the value of Kb and UB now. What is the value of Kb plus UB? Because Vb square you got there, so this will be half m Vb square mg into h minus mg h sin theta. This one you got half m 2gh sin theta plus mgh minus mgh sin theta. These two get cancelled. So total energy at B is also mgh. Okay? Total energy at B also mgh. What happened at the bottom of the incline, at the point C? This we have to find. Height is h, theta at this point. Here you have just released A and this is C. At C, K plus P will be what? Tell. K is half mv square. It touches the ground. Potential energy will be 0. Now Vc square how to get? Va square plus 2g sin theta into AC. Va is 0. 2g into AC sin theta. AC sin theta is what? 8. So this is going to be half m into 2gh mgh. So energy at C you got mgh. Energy at B you got mgh. And energy at the topmost point, what have you got? That is also mgh. So total energy is conserved over there. Clear? Understood? When you are going to calculate any kind of potential energy, then we will be using this formulation. From A to B minus Fc dx equal to du. Okay? It is better you write here also A to B. UB minus CB or delta U. That we are writing. That's why I told you we maybe mathematically not very correct. You can write delta U from A to B or A to B du integration minus Fc dx. So whenever you are going to calculate, one thing you remember, let there be a force which equals with the conservative force. This is conservative force, no? Let there be a force F dash equal to minus Fc. Then we can write this as A to B du equal to A to B F dash dx. You can write this. This F dash is what? This F dash is balancing the conservative force. Okay? So for gravitational P, you are taking it from the point A to the point B. Height is h. Now if you apply this equation, A to B du, or simply delta u A to B is what? Use the definition. This definition you will never forget, I am telling you. This is very important. Understanding of electrostatics will not be possible without knowing the true concept of conservative force and work done. Okay? So, UV minus UA will be, what is the force acting on the object? Tell, throughout the path, mg. Because for a small height, G is uniform. So you assume that mg acting everywhere. So if you write Fc, force of gravity, it is minus mg, isn't it? Downward, you are taking it upward. So if that's going to be what? That force balancing minus mg, this will be mg. So you put mg into dx A to B. That is mg. This is what? Potential energy at A minus potential energy at B, and this position at A, position at B. So you write HAHB minus HA. Okay? Height at B minus height at A. Now what? Now, there is very interesting thing. Should I put mgh is 0? Who gave you the power to put mgh is 0? Why? You can take anything. Somebody says that no, you don't take h is 0. That mgh is 0, you don't take. You take at a depth 1000 km below the earth where potential energy is 0. So, one thing I will tell you today, wherever you take the origin, it's your choice. It is origin independent. Origin you have the freedom to take anywhere that origin. So, if you write UV minus UA equal to mg HB, on the ground I am taking 0 and UA also 0. Potential energy at A equal to 0. This is arbitrarily chosen. This UA equal to 0 chosen arbitrarily. Somebody can take some different answer, no problem. So UV minus 0 equal to mg HB. HB we have taken H above the ground, so potential energy will be mgh. You do integration, you do this method, it will be the same thing. For a spring, what happened? Potential energy is stored in a spring. Same concept, conservative force here also. This is the spring, force constant K, natural length L0. Applying a force, maybe compressive, maybe used for elongation. Okay? So, if you have elongated by x, this is external force, and spring force just opposite. If spring will be what? Force due to the force developed in the spring, that is spring force, this will be minus kx. Okay? So, how to calculate the energy of elongation. Initial elongation is 0. So integrate this one, du. Initial potential energy also you assume 0. And here it is u. Just write u equal to minus kx dx 0 to x, but the angle is 180 degree. So there will be k outside 0 to x, k into x square by 2. So u going to be half k x square. If there is some initial elongation, let the spring be elongated from x1 to x2. x1 is the initial elongation, x2 is the final elongation. Then 0 to u du will be x1 to x2 kx dx. So k will be outside. So u will be k by 2 Am I correct? So change of potential energy, initial minus final. This you can write u2 minus u1, or that energy stored, potential energy stored. Work done you calculate first, then from there change of potential energy. Okay. So I hope you have understood the concept of conservative, non-conservative force, and next session I will be discussing some standard problem based on it.